Let's say I have 6 different colored M&Ms, and I have 3 different colored Sharpies, and I'm allowed to take one M&M and one Sharpie. How many different ways can I do this? Let's count. Eighteen ways. To do this without actually counting all the possibilities, I can take a look at the choices I make. So choice 1 can be what color Sharpie do I want to pick, and choice 2 can be what color M&M do I want to pick. Then we can list all the different choices in a tree-like shape. And so we take all these different parts, orange, purple, green, and then we list all the different M&Ms after them. And each of these different ways will tell us one way we can pick it. Count them all up, and you have 18 total ways. If you look at it another way, that's 3 branches times 6 branches each on those. That's 6 times 3. The multiplication principle says that this exact process works. If we have to make 2 consecutive choices, then we can find out the total number of ways we can do that by looking at the number of choices we have for each of these 2 choices. So if choice 1 and choice 2 have m and n different options, then the total number of choices I have is the product of the two, or m times n. In the first example, we had 6 times 3 different choices. We can generalize this to any number of choices, just multiply all the choices together. This is the top panel for the amplifier that I use for my guitar. There are 5 different switches, each of which alters the sound. Most of them are two-way switches, but one of them has 3 positions. How many different sounds can I make from this amp? Well, we look at all the choices we can make. So the 5 switches and their positions are our 5 different choices. They have 2, 2, 2, 2, and 3 different ways we can put each switch. And so the total number of ways I can flip the switches is the product of all those numbers, which is 48 different ways. I had the 7 Harry Potter books on here, and I want to see how many different ways I can rearrange them. The answer is obviously only 1, because, they have to be in order. A better similar example is, let's take a look at some games on a shelf. So we have 8 different board games on this shelf. How many different ways can I arrange them so that they're all still on the shelf? Here at the 8 games, we have 8 different choices in order to pick the first game. And so we pick one of the games that will go on the shelf, and there's 8 different ways of doing that. Now we have 7 games left. So there are 7 different choices for which game goes second. We pick one of them, put it on the shelf. There were 8 times 7 different ways of picking those first 2 games. 6 choices for the third game. We'll then pick that, put it back on the shelf, and remaining is 5 different choices for the fourth game. At this point, we have 8 times 7 times 6 times 5 different ways of putting those 4 games on the shelf. With the 4 games left, there are 4 choices to pick this game. Put it on the shelf, and then multiply that by our total number of choices. 3 games left, so 3 choices. 2 games left, only 2 options for this choice. Finally, there's only 1 game left, so only 1 choice for the last spot. Now the total number of choices that we made is just the product of all those choices we made together. So it's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 40,320 different ways to arrange these games on the shelf.